this meeting is being recorded. We are doing this as a meeting so we can collaborate and talk with each other. The point of the network is to groups of MIT alums who may not know about the work others are doing. So our purpose is to inform folks about climate and energy and sustainability, connect alums, and then for those alumni groups to take action. And in that aspect, we definitely are more than just MIT alums because they're free to do it. The network is focused on alums, but the work that the groups do is not. We do online events once a month, and at this first forum is kind of a lightning round of presentations on new businesses for a sustainable future. There's going to be many other venues to collaborate and have discussions. So Irshad, why don't you tell us a little bit about the group itself?
My pleasure, Sarah. First of all, welcome to the first forum of the Climate Business and Innovation Group that kind of came out of Energy, Environment, and Sustainability Network of MIT alumni around the world. It's really my pleasure to invite you to the first forum, and I hope this is the beginning of many to come in future. Let me frame the need and the reason we decided that we needed something like this for to exist. The MIT Alumni CBI group is committed to advancing business and technology innovation that can achieve a sustainable future for society, economy, and the environment. The timing couldn't be better. We should have done this years ago, but here we are. So my hope is that through these initial collaborative platforms and after this first forum is behind us, that many of you will find this as a perfect platform to collaborate, to share with the rest of the MIT alumni community what you're working on and how we can help each other. Thank you, Sarah.
And then Alex, let's hear about this forum itself, what we're about to try and do with this time for the first time.
Thank you so much. This forum is designed to increase the level of collaboration between MIT alumni. In my 25 years of innovation and working across the world, we've seen really collaboration across multiple different parties is one of the key ways of increasing technology deployment and improving results. And really, I think there's been a lot of MIT frustration and the alumni in terms of being able to bring our skill sets together. This forum is here for alumni who are interested in climate and business and innovation, for each of us to either bring our ideas or businesses or projects to the table and to seek feedback and then longer-term collaboration with our fellow alumni for the purpose of long-term impact and improvement of our mutual goals and concerns around climate change. This forum will be taking place regularly, and then as after action on this forum, we are also co-launching a global collaboration program and platform where the different speakers will upload information and which will be a venue for longer term collaboration. So keep an eye out as participants for an ability to join that platform to see further information and to if you want to choose to collaborate through that platform. Overall, we really look forward to growing this forum and bringing on further speakers and really engaging the community to make the climate impact that we all believe is so important. So I hand that back to you, Sarah, and Irshad to kick things off.
Okay, Irshad, it's time to present your business.
Love to do that, and thank you for the invitation. Let me see if the slides, can you all see my slides?
Yes.
Perfect. So let me take a second to reintroduce myself. So I'm Irshad Ahmed. I'm a chemical biological engineer by training. MBA class of 2012 from Sloan. And I am a serial entrepreneur. As you will see that theme kind of running through today's forum as you hear others today at this forum. So I've done about 8 companies focused primarily on renewable and clean energy technologies. The company that I want to talk to you about today is AurisEnergy. It's a company that's focused on liquid transportation fuels. I will start with the obvious. The obvious is US 5-6% of the world population, we are gas guzzlers. We consume 25% of global supply of oil and gas, which is a pretty significant problem to kind of go into energy transition mode and change anything. But my narrow focus of today's talk is biodiesel. We have additized 10% of our entire liquid transportation fuel cycles with ethanol. And then we are now doing the same thing with biodiesel, which is made from agricultural crops and whatnot. Okay, so obviously you all familiar with that the 2020 pandemic kind of shifted the gears. As you can see, transportation sector has become leading polluter of everything that happens in the climate impact zone, and petroleum is the leading cause of it. So we need a substitute. The industry itself in the United States is a long history. The biodiesel industry goes back to about 50 years. The recent renewable fuel standard by the US government is calling for replacing 25% of all our liquid transportation fuels with biofuels, which is mostly ethanol and biodiesel. This is a pretty important tool towards achieving the net zero objectives for the country. Pretty significant markets, about 6 billion gallons per year, which is still a drop in the bucket as you saw the numbers before. Nevertheless, we have mandated programs under EPA and renewable fuel standard that is pushing us towards significant numbers. So this year alone, EPA mandate is to replace 22.5 billion gallons of diesel with biodiesel. Significant public policy drivers pushing it: California low carbon fuel standards, RFS, state European Union directives, and significant activities under, and the money is available to support the incentives. Our vision at AurisEnergy is to become one of the leading global market leader for producing low cost of premium biodiesel, high purity glycerin, animal feeds, and alternative agriculture. The idea is to integrate agriculture with manufacturing, and that linkage is a critical piece to our success. Company has raised quite a bit of money already. We sunk in about 10 million of our money. We have commitments for 80 million in debt financing, and we are currently working to raise about 20 million in equity or preferred structured debt financing to complete the first round of $100 million to get our phase 1 and phase 2 in place. Number of projects on the drawing board, so this is kind of the tip of the iceberg, but I present this as a case in point. The challenges that we face, and I want to bring the focus to why we are here today, is there is a huge disconnect. And all of you who are in the clean energy space have probably felt this. There's a disconnect between energy and agriculture financing. There are very different people who think very differently in the financial communities when it comes to energy investments, real estate investments versus agricultural investments. So traditional financial models don't kind of work. They just fail miserably when you're talking to one versus other group. There's very poor understanding of biofuels market to begin with. So there's a gap there, and there's a steep learning curve every time you go into a pitch. We have explored a number of financial options. I mean, private equity, those come to mind. The most recent one I'm doing right now in real time is GSD-based tokenomics, security tokens, and that's an option available to us. So we are working on. Meantime, significant activities are going on in the industry, some significant announcements. I will point out the one, which is number 3 on the right side. Chevron just bought Renewable Energy Group for $3.15 billion. It's a biodiesel company. So with that, I'm going to stop there and will certainly be available to answer any questions and discussion during our breakout session. Thank you.
Thank you so much, Irshad, and for the folks on the line. We'll be doing a really quick feedback from myself to Irshad and kind of from folks on our kind of committee. And then, as Irshad noted, there'll be an opportunity to go into a breakout room to talk to him directly and ask questions. Irshad, kind of my kind of main kind of question coming out that I'd like to kind of ask you is, you laid out kind of, I think, pretty clear case that you're kind of in between the ag investors and the energy investors. What are you kind of looking for specifically for folks here? Are you looking for people who have kind of had a foot in either or both of these areas, and that they can really find the kind of the correct language to kind of express this? Or is it, we're not, raising particular, money through this, but people who understand how to raise money, spanning both sectors? Can you kind of get into that kind of area? What's really most helpful?
Look, you put your finger on the nerve on this. So the recent experience, the last year and a half, now of course, rising tide lifts all boats, and world is on fire, and we are at war, and climate is causing all the devastation. So there's lots happening now, and there's incredible amount of money moving into the renewable energy, clean energy sector right now. But the challenge, I think, is I need help from strategic guidance perspective, or identifying strategic partners that can bridge some of these gaps. So whether it's an airline, whether it's a transportation company, whether it's segments in the economy that kind of piggybacks on both sides and straddles between those. That is, I think, is the ask of this community today, because one is, how are we pitching? So I have pitched and failed numerous times to people who are very familiar with the energy sector. I mean, big, large funds like Macquarie and ARC in Canada, and several other Hudson Capital Partners, whatnot. We don't fit in there because I lose them when I start to talk about integration of agriculture and feedstock supply chain. Unfortunately, with the soybean oil prices going through the roof and how the climate change has disrupted the supply chain, not just on the food, which is coming, by the way, but it has also disrupted the supply chain for raw materials going into bioenergy systems. So our thinking was, it was a natural to do that bridge, but I lose financial community when I present that bridge.
Thank you. And I think there's time for one, maybe I'll raise a point that maybe can be discussed further here. It seems, in the breakout, it seems one of your clear differentiations is being able to use marginal land versus ethanol and other fuels. I think this would be a really good breakout room topic, because I think that's a differentiation that perhaps you haven't explored as well in terms of getting carbon credits for improving marginal land, and at the same time creating a sector. So there seems to be perhaps an opportunity to create a new vertical that ties in carbon credits at different levels, but that will have its own challenges about bringing new stakeholders together. But perhaps there's something there that people in the breakout rooms can think about. Is like, is there a completely different vertical or horizontal that you can pitch to that you haven't tried before that may be more receptive? So just kind of rather than trying to find ways to do your box, maybe move into someone else's box. So I think at this point we need to hand over to the next one and look forward to people joining this breakout room and getting further feedback.
Thank you,
Alex. Sarah.
Thank you, Alex.
Next up, go ahead, Herb. You're the next up.
I think I'm the next up, and Amy's going to share my slides. So Liquid Cool Solutions offers a proprietary ultra green technology for cooling IT equipment of any shape or size, while slashing energy use, eliminating water consumption, reducing space requirements, and isolating electronics from pollution. Next slide, please. Amy. Okay, we have 59 patents worldwide. Although there's a broad range of technologies that these patents encompass, the primary focus is what we call chassis or rack-based single-phase immersion. So we use standard racks And we immerse all the electronics in a dielectric liquid which conducts heat but not electricity. It's commonly available, usually used by the electric utilities for cooling of high voltage transformers. Next slide. In a liquid cool world, the waste heat from servers can actually be recovered and reused. We can create a zero carbon edge computing system by basically taking all the rack energy and heating hot water to 60 C or 140 F. The electronics are isolated from pollution. No water is consumed. This is a big problem in many parts. For some reason, people continue to build data centers in the desert, but we consume no water and we require no air conditioning, as long as it's cooler than 115 degrees Fahrenheit outside. E-waste is reduced significantly because we can reuse all the components on the next generation, except for the boards themselves, which are updating. The data centers run silently. The dielectric heat transfer liquid we use is non-volatile. It's never replaced. It's safe to handle and has a global warming potential of 0. And most causes of server failure are eliminated because there's hardly any moving parts. Next slide. We have two basic products, what we call the LCS ZP server and the LCS mini node. The ZP server fits in standard racks and can be located in data centers or edge computing centers. The mini node is designed for harsh environments, can be located even on street lamps for 5G nodes. These can be located anywhere there's power and fiber. There's no other infrastructure required. The field setup is rapid. They're extraordinarily energy efficient in the parlance of computing IT equipment. It's the PUE, power utilization effectiveness, is less than 1.03. No water is consumed, as I mentioned, easy to maintain. Electronics are protected from pollution, as I discussed, and the chassis and all the dielectric liquid can be reused. Next slide. Third-party verification. NREL tested our technology in their ESIF data center in Golden, Colorado for 2 years and calls us the gold standard for cooling electronics in building connected data centers where heat's reused. They also found that in 2016, if data centers had used our cooling technology instead of what they had been using, principally air, there would have been a net savings of 13 million tons of CO2 in the US. Lawrence Berkeley Lab tested us for the Navy in a program called Tropic and found we were 30 times more efficient than air cooling in tropical climates. Intel tested the technology for compatibility with its electronics as far as the fluid itself. And last year, the Solar Impulse Foundation certified us for listing on their companies, international companies that can be profitable and serve the environment as well. And open compute now, which is becoming increasingly important in the industry, is beginning to standardize around various forms of liquid cooling. Next slide. The addressable market for our technology is pretty much everywhere from the far edge all the way to hyperscale data centers. It's a $500 billion market. We're focusing initially on edge computing, about 60 billion, data centers about 60 billion, and harsh environments around 10 billion. So about 130 plus billion is our addressable market that we're focusing on, although I believe that there'll be, as the deployments become that there are more deployments, I think we'll find that other markets will adopt the technology. Next slide. Competitive landscape, to our knowledge, there's 12 companies right now offering, including us, offering immersion cooling, which we believe is the end game for cooling electronics. It's the most efficient and energy efficient and environmentally responsible way to get the job done. 10 of the 12 use tanks rather than racks, and 2 of them use what we call two-phase cooling, where they actually boil a refrigerant. Tanks are basically less efficient than racks in terms of space utilization and weight. Boiling is a challenge. It's a highly volatile refrigerant they use, which has a global warming potential. It's better than it used to be, but low-tar cigarettes are still cigarettes. And there's also potential health challenges associated with inhaling the vapors. Among the competitors, only one uses rack-based technology. And actually, as a result of a recent court case, there's many markets in the world they cannot access because of our technology patents. Next slide. ESG considerations, direct emissions. We slash the need for IT hardware and support. We reduce power consumption significantly, but up to 40% in a data center. Upstream emissions, we of course use less electricity, which helps at the power plant, but we also have fewer transmission losses along the way. And downstream emissions, because we don't, the only thing you need to change in a technological upgrade is the board. All the other components can be reused. So you don't throw the servers out, you just change the boards. Other environmental impacts, we don't use water, or we don't consume water. And again, the heat transfer fluid has a global warming potential of 0. Next slide. And that's me. So what we're looking for in the way of advice is, we found that seeing is believing, and we want companies to try it. We want to create a program for companies to try it and compare it to what they're doing now and what other options they think they have. So I'll be looking forward to your good advice on how we can accomplish that, what kinds of programs we should establish to get a broader deployments in the field. Thank you.
Thank you.
There you go.
Great presentation, sir. Just a quick fun question. How many cryptocurrency people have asked you about your technology?
A lot. And we actually have a very unusual design for crypto, which we've used and tested. We think that's a big market, but we think that we have a greater competitive advantage in other markets. We bring more value to other markets that are less controversial.
Understood. You know, I asked you that because your technology here is only speaking to data centers. There are a lot of power electronics and other things, and you alluded to that it could be used within utilities, but batteries and others. Could you speak to your patent coverage there as well?
So we have 59 patents granted, 16 pending around the world. And they're different. Some of these patents are long established, over 10 years. Others are relatively new. There's a whole range of pieces that you have to put together to make this work in a data center or in the edge computing world. And so they cover pretty much all of those pieces. The way the flow is managed, one of the important patents we have is called directed flow, where the coolest liquid goes to the hottest components first before merging and melding with all the other fluids in the chassis. And so that's important because it enables us uniquely to get 60 degrees C output if we want to reuse heat.
Okay.
So it's a very important. Our patent portfolio is a key value proposition for us in terms of offering benefits to users.
Now, given your ask, if you're looking for introductions, what is the title of the person that we need to know to offer you that assistance?
Chief Sustainability Officer. We find that engineers are just difficult gatekeepers for a whole host of reasons. That's our experience. But the recently created position of Chief Sustainability Officer is a person in these large companies that actually looks to try new things and upset a bit. They can get past the engineer gatekeepers sometimes to create tests and trials.
Okay. And for a test, is there any money up front, or how would the person making the introduction pitch what you have to offer?
Well, we've tried try and buys in the past, And the challenge is the try never stops and the buy never starts. So what we've been proposing lately is buy and then we'll buy it back if you don't want it, to show some interest in trying it. But then we'll, if it doesn't meet their expectations, we'll buy it back.
My last question before I get in trouble. Some people like to do things after they retire. And so if you are hiring, which disciplines are you looking for?
Well, we're moving into the marketing phase. It's been pretty much science up till recently. We started, science morphed into sales maybe a year ago, but the pandemic created some issues there. But we're now moving into marketing, and the skill sets we need from retired people are people that are well connected in the technology world. What's happening is a tectonic shift in computing, where a lot of the computing assets are moving to the edge of the network for various issues of latency and other things. And we do bring a huge value proposition, but convincing people at the lower levels, the new levels of these large companies to try it is difficult, but well-connected people who had a ranking in these companies, the relatively high ranking, can get us in the door. And I think once we're in the door, it becomes a simple, relatively easy sale process.
A nice presentation. Thank you. Very good. Now we're up to our third presenter, Luc Frechett with CSAR Energy. And Luc, take it away.
My pleasure. Nice to meet you all. My name is Luc Frechett. I'm a professor in Canada at the University of Sherbrooke and an entrepreneur. So it's a pleasure there to be able to be here today and share our innovations that we have in the area of decarbonizing hydrogen and syngas production. So it's technology that emanated from the desire to reduce the impact of this $100 billion industry, which unfortunately today, even if we think of hydrogen as clean, the way it's made is not clean. So we wanted to address that using renewable energy. So today it's really reforming that is used to create hydrogen, but also syngas used in many chemical processes. And this actually leads to a fair amount of CO2 emissions, actually equivalent to the aviation industry. And this is with today's consumption of hydrogen. So seeing the interest as hydrogen as an energy vector, to be able to use that for transportations, for large vehicles, for example, and in industry, it will grow. It'll be even more of an interest and a vector of growing interest. However, we really need a change in how it's generated. So, of course, there's electrolysis, which is very appealing. It's unfortunately a very large consumer of energy, of electricity, which is only partially green on our grid. So that also has its limitations today, in addition to the capital expenditures and the cost of the hydrogen that comes out of doing electrolysis. So we were thinking about other approaches. Typically, if you look at how it's made, you'll use your sources, natural gas and water, and you'll use heat. Actually, a fair amount of heat. 40% of the natural gas you will burn actually to generate heat. And this combustion leads to a large portion of the CO2 emissions. So that got us thinking about how we can do it differently at CSAR Energy, which is a startup that emanated from the university, by using renewable sources for your heat source. Can be electricity for omic heating, or direct solar concentrated heat that would be directly applied onto the reactors. We also run it in a mode where we can consume CO2 in order to contribute to the process. So by doing that, we can have greener outputs with up to 40% less CO2 emissions from this process. One can go further and sequester the CO2 and go to net zero, or go even further and use biogas as your feed, and then go carbon negative. So there's a path there in the future to also continue using this process, even well beyond where we are today in focusing on fossil fuels. Biogas will always be there. Decomposing matter generates biogas, a mixture of methane and CO2. And this technology allows us to actually consume that and make the most out of it. So at the heart, we have a core technology, which is coal shale architecture reactor. It's actually a relatively small unit here if we just look at the size. And we have inlets at one end and the other end, which is heated. The principle is that inside we integrate the various steps that we need for the process, such as counterflow heat exchangers to do waste heat recovery, a micro-scale reactor bed that has optimized heat and mass transport in order to also optimize the use of catalysts, as well as an interface that allows heat source integration. So either direct electrical heating, radiative electrical heating, or direct solar. So this approach actually is a bit different from doing a typical reactor, since here it's not scaling it up by making it bigger. It's scaling it up by multiplying side by side these unit reactors that are really optimized. If we look at how this can be done or implemented to scale up, the reactor is like a slice essentially that we come and we fabricate in large quantities, as we would do for solar panels or other large scale manufacturing, and stack them up. And when we want to go further and scale this up to the volumes that are needed for large scale hydrogen production, well, we parallelize this. So we put these together in terms of having large surfaces, which can be the focus of a solar concentrator or direct heating. Then these could be combined together into a unit volume, so the container scale. So for example, this 1 meter cube container here can generate on the order of tons of hydrogen per day. So it's very dense, very compact. It's about 10 times more compact than a typical steam methane reforming system. So you can actually have imagine this to be distributed. So suddenly, where you have natural gas or biogas, you can go ahead and generate hydrogen locally without the needs for transportation, which is a big cost actually of making hydrogen accessible and deploying it. So it changes the framework of how we do hydrogen. It can be distributed, it can be scalable, and it can also meet the larger scale by combining these together, going towards commercial plants. So it's a different way of doing things. Why is it interesting? Well, really what's hiding in the reactor is what makes it very interesting and promising. So we have developed this technology out of the lab there for the past 5 years, starting from the initial prototypes, bringing it on sun and operating it with solar concentration, also shifting over to electric heating to use renewable energy. So up to kilograms per day. So we're definitely at the stage of continuing this scale up, which essentially is more of an integration challenge than actually a reinvention or re-engineering of the reactors. So the reactors actually have shown reliability, and here it's 200 hours, but we're going towards 1,000 hours as we speak. Both versions have been demonstrated up to TRL5, so in relevant conditions, but still need to be further integrated. And we've shown two operations. One is with water as an input, so steam methane reforming, and the other one, which is dry methane reforming, or DMR. That's the approach which consumes CO2 as an entrant in the process. So we have this compatibility with biogas, which naturally has CO2 as part of it. So instead of trying to split it away and then do something, figure out what to do with the CO2, well, this can feed into the reactor. Like I said, it's also very dense in terms of power, and that has an impact on capital expenditure. So we just have much less material to start off with, especially given that we integrate different steps of a process, which are usually independent equipment, all together into one unit, such as the heat exchanger. It is very, very efficient, and it has a direct impact on CO2 generation. The output from the reactor doesn't have combustion as part of it, so it's very clean and makes it easier then to use and easier to do sequestration. So if you want to take the output of a system and put it underground, if you have 40% less CO2 to store, well, it'll make that part of the process much cheaper and easier to implement. So it's more compatible actually with sequestration than standard SMR that uses combustion. And it's scalable, and compared to electrolysis, the hydrogen cost at the end is a few times cheaper, and the capex also is dramatically lower, which actually makes periodic operation more viable, more interesting. If we think of being able to use hydrogen as a storage for electricity that is beyond what we need to consume. And sometimes if we have extra solar or extra wind capacity, well, if you have equipment that is only used part-time, it makes it very challenging for the numbers to work when it's expensive. So it allows this to
Luc, we're
happen.
running out of time for your feedback to everybody. We will have the breakouts, but if you can wrap it up, that would be great.
I'm doing that right away here with, as part of the team, actually, we have an opportunity for someone who wants to lead such an activity. So there's a CEO opportunity to jump in and have a main role to play. In addition to helping us to find the good match with this technology and the market in terms of fitting it with the process, which either needs this low carbon hydrogen or has sources available. So if you can help with that, it would be greatly appreciated. Thank you so much.
Oh, thank you, Luc. This is Irshad. Thank you for that presentation. And I think as far as we are talking about climate business and innovation, you pretty much covered the climate impact part and the innovation part. It's a pretty innovative idea. So thank you for that. I'm going to zero in on the business part, right? Because at the end of the day, it's the commercialization. It may be the best mousetrap. If the world doesn't see it, it doesn't exist. Can you identify 2 or 3 key elements, what you like to see happen for this product and this company to take it all the way to commercialization? Is it capital? Is it strategic partners? Is it a proof of concept in the real world? What are you looking for?
Yeah, so it's to scale up to a proof of concept pilot, which would be in the tens of kilograms per day to start off with the potential to scale it up to the ton per day of production. This would bring the validation of its applicability for that given partnership, for that given application, while allowing the system level components also to be developed in costs and size, so that one can really see what will be the real cost once you bring this out on the field and implement it. So for now, it's really partnerships, strategic partnerships, in order to do the pilot scale, which is the big thing missing.
Now, one small question on the financing side. What kind of rounds have you raised up until this point, and what are you looking for? What's your next round? How much capital you need to really take it to the next stages of the growth?
So the really focus is a bit more on the team than the money. We have a lot of people who are very interested to support, but we need to have a stronger team to be able to deliver what we have there. So it's really emanated from a student team per se, and then the students are going on to do other things with their careers. So we think there's the opportunity there to open the door to someone who's more seasoned, someone from the oil and gas industry or the chemical processing industry wants to jump in. And funding, like I said, we've just been saying no and saying it's not the time yet until we have the team. So but in order to do the next stage, it's a few $1 million that need to be put in, but it's not that dramatic actually to get the ball rolling.
Thank you, Luc. I'm going to keep us on clock. So thank you very much for moving the needle on hydrogen from blue to green. I think that's what the world needs. And it looks like it's a good disruptive technology. And we'll pick this up in the breakout room. So again, thank you, Sarah.
And it can be used for your biodiesel too, probably.
Yeah,
but anyway,
we'll have an offline conversation.
No, we don't have time. We're about to go to breakout rooms. We can't have 2 10-minute ones. We are going to run a 10-minute breakout room. People can choose which room they go to. But first, you might like to look at the chat. There is a way to save that chat, or just go to the company you wanted. Their slides are available as a URL. Decide which room you want to go to. After 10 minutes, we will say that there's an opportunity to switch rooms if you choose to. And then we will come back at about 2 minutes before the end. So your discussions are going to be right in the breakout rooms, but we will also have information, and we will follow up with anyone who wants more after. So Amy, we're up to breakout rooms, and Moana, join a breakout room. There you go. I wanted to thank all of you for coming. This was very exciting for me to see some of this. I'm an engineer, and I like having the solutions. Doing all the policy, yeah, we have to do it, and I know something about that. But The group welcomes you to be a member. So if you've put your email into the chat or you've just told people in the rooms that you want to be on the group's mailing list, that's good. We would also really appreciate having you on the EESN mailing list. If you go to our website, which is eesn.alumgroup.mit.edu, you can go to our participate page and sign up for our email. We only send 2 emails a month. And we're very delighted that you all could come. They've put the finish sign up, but if anybody else, slide, I should say, if anybody else wants to comment just another couple of minutes, they told me that they weren't going to shut us off straight at 2 o'clock. So I want to thank Luc, I want to thank Irshad, and I want to thank her very much for coming and doing this first presentation, first forum for the CBNI group. Alex, would you like to close with anything else?
Thank you everyone for joining. Very exciting. You'll be getting some follow-up emails, including this collaboration platform that we're testing, which will hopefully enable people to work together much more seamlessly. Thank you again. We look forward to doing future events, and hopefully you'll be coming back and joining. Working
together can really produce some incredible synergies, and it's a delight to have you all here. Thank you. Okay. I think
Thank you very much.
Thank you.
Very good.
Take care. Great job.
Thank you so
guys.
much. Bye-bye.
Hey, thanks.